Hello everyone! In this lesson, we will introduce the knowledge of power capacitors. We will mainly cover 5 aspects, which are the types and functions of power capacitors, basic structure, model, reactive power compensation, and usage knowledge. First, we will introduce the types and functions of power capacitors. Power capacitors can be roughly divided into 5 types based on their functions. First, shunt capacitors. Shunt capacitors are connected in parallel to the power grid to compensate for the reactive power of inductive loads in the power system to improve the power factor, enhance power quality, and reduce line losses. Second, series capacitors. Series capacitors are mainly used to compensate for line reactance, improve the voltage level at the end of the line, enhance the dynamic and static stability of the system, improve line voltage quality, extend transmission distance, and increase power transmission capacity. Third, coupling capacitors. Coupling capacitors are mainly used in high voltage and ultra-high voltage transmission lines for carrier communication systems. They can also be used as components in measurement, control, and protection devices. Fourth, equalizing capacitors. Equalizing capacitors are generally connected in parallel across the breaker contact to ensure that the voltage across each contact is evenly distributed when breaking. Fifth, pulse capacitors. Pulse capacitors are used for pulse voltage division, oscillating circuits, rectifier filtering, etc. Here, we will mainly introduce shunt capacitors used for reactive power compensation in the power grid. Next, we will introduce the basic structure of power capacitors. Shunt capacitors mainly consist of capacitor elements, impregnating agents, fasteners, leads, cases, and bushings, as shown in the figure. Capacitor elements are made by winding aluminum foil electrodes with a certain thickness and layers of solid dielectric, as shown in the right figure. In high voltage capacitors with voltage of 10 kV and below, each capacitor element has a fuse in series for internal short circuit protection. Impregnating agents to enhance the dielectric strength of capacitor elements, improve partial discharge characteristics, and heat dissipation conditions. The capacitor core is generally immersed in mineral oil, chlorinated bisphenol, SF6 gas, etc. Case bushing. The case of the capacitor is generally welded from thin steel plates for better heat dissipation, but the insulation performance is poor. Next, we will introduce the model of power capacitors. The model of capacitors consists of letters and numbers and is divided into 6 units. The first unit has 4 letters. The first letter is the series code, indicating the purpose and characteristics of the capacitor. The second letter is the dielectric code, indicating the type of liquid dielectric material. The third letter is also the dielectric code, indicating the type of solid dielectric material. The fourth letter indicates the electrode characteristics, where J indicates metallized electrodes. The second unit indicates the rated voltage in kilovolt. The third unit indicates the rated capacitor in kilovar. The fourth unit indicates the number of phases: 1 for single phase, 3 for three-phase. The fifth unit indicates the usage location: W for outdoor use, no marking for indoor use. The sixth unit indicates the suffix code, indicating additional characteristics. Next, we will introduce reactive power compensation for power capacitors. First, principles for configuring compensation capacity. The configuration of reactive power compensation capacity should follow the principles of comprehensive planning, rational layout, graded compensation, and local balance. Second, compensation methods. Compensation methods based on the installation location can be divided into centralized compensation and group compensation. As shown in the figure, this is the writing diagram for centralized capacitor compensation. Centralized compensation means that the capacitor bank is centrally installed on the primary side or the secondary side bus of the substation. Automatic control equipment is installed to automatically switch the capacitors according to load changes. Group compensation. Group compensation means that the capacitor bank is divided into groups and installed in each distribution room or on each branch line for simultaneous switching. It is generally used in places with small compensation capacity and many scattered electrical devices or places with relatively large partial compensation capacity. Finally, we will introduce the usage knowledge of power capacitors. Inspection and maintenance. Before commissioning, it should undergo acceptance testing and meet the qualifications, with reasonable layout and firm connections. During operation, check that the case should not be swollen, no oil leakage traces, no abnormal sounds or sparks. Fuses, discharge indicator lights should be normal. Record the readings of related voltmeters, ammeters, and thermometers. If necessary, you can briefly power off and check. Switching the capacitor bank on and off. The switching of the capacitor bank should be based on the system's reactive power load flow, load power factor, and voltage conditions. When the voltage is low, the capacitor bank can be switched on. When powering off, in addition to automatic discharge, manual sufficient discharge should be performed. Otherwise, do not touch the capacitors. After the capacitor bank is disconnected from the network, do not reconnect it immediately. If immediate reconnection is necessary, ensure that the terminal voltage is not higher than 10% of the rated voltage. When performing a complete power-off operation, first open the capacitor bank switch, then open the switches of each outgoing line. When restoring power, first close the switches of each outgoing line, then close the capacitor bank switch. This concludes the content of today's lesson. Thank you, everyone.